Alright? Okay, we look at job scheduling. Now, job scheduling. Job what? Scheduling. Now, the word job, first of all, means tasks. Whenever you see the word job in computer science, we're referring to tasks. The tasks the computer is supposed to do. Open the file, close the file, log in, all those things. Print, those are called jobs. Then the word scheduling means arranging. Arranging. Now, job scheduling, if you combine it together, this basically looks at how the operating system arranges the jobs or the tasks in the order in which they should be performed or processed. The logic behind is we have so many jobs. We have task 1 or job 1, we have job 2 or task 2, and we have task 3. They all need to be done by the computer. But the computer is supposed to do one at a time. Why? Because the processor that performs these jobs possesses only one job or handles one job at a time. So now here, if I'm having 3 tasks that have to be done, then the operating system must come in and say, okay, how can I arrange you? How can I arrange these tasks? So that the processor knows that I should begin with this one, I should end with this one, I shouldn't do this one right now. Are you getting me? Basically, the processor is trying to know which job should I do first? Which one should I do next? Which one should I do last? That arranging jobs or tasks in the order in which they need to be performed is called job what? It's called job scheduling. And it is done by the operating system. It's done by the operating system. I think you've understood that now. When is it done and why is it done nowadays? It's because these days we have what called the multi-programming computer system. Multi-programming means before, in the old days, like before I think the 90s, the computer systems that we are having were only single programming computer systems. What do you mean by that? When you open Microsoft Word, you can't open any other program until everything you want in Microsoft Word is finished and you've closed Microsoft Word. When you open WhatsApp, only WhatsApp will be allowed to be open. Jonathan, tell those guys to go up. Just the outside there. Tell them to go up. Your troops. They are moving away. Call them and tell them to go up. They're moving away. So now, but nowadays they said no. Why should we have only one program using up the computer and we have to close that program before we open another program? Nowadays it's different. You can open WhatsApp, you're on Facebook, you're on Instagram, they're all open, especially on your phones. They can be open, the background, they are there. Which means now, in this case, the computer systems are multi-programming what? Computer systems. They allow multiple programs to be open on the computer. But when those programs are open, it does not mean that all the instructions are done at the same time. No. Only one instruction has to be done at a time. And this is where now job scheduling comes in. Because you might be on WhatsApp, your WhatsApp is open, but I send you a message maybe on your email. And you need to open that message. Which means in that case, if you're not using WhatsApp, even if it's open, it means now in that case, the other one needs what? Attention. That needs to be attended to very fast. So in this case here, the person comes and says, no, let me choose an order in which, let me choose which one should be done, which task should be done first. However, the problem is, how does the computer know, or how does the operating system choose? And this is what I want you to understand well. The operating system chooses the task to be performed, or the order in which they should be performed, by assigning what you call what? Priorities. It assigns priorities to the tasks. It attaches what we call importancy. This is more important than this one. This one is more useful than this one. This one is more needed. So that importance, what we call prioritizing the priorities, by attaching or assigning priorities to the jobs, it means that the operating system is deciding how important is each of the tasks. Now, the one which is the most important is the one that is chosen to use the processor first. So the one which is given the highest priority is the one which is organized to use the processor first. And that's how the operating system does scheduling. By seeing which jobs are more important, are you getting me? And assigns them with the highest what? Priorities. Or it compares the importance of the tasks. And the one which is more important, it's given a higher what? Priority. It's chosen first to use the processor. I think you've understood that. Next, what factors does the operating system use to determine which tasks or how important the tasks are? Which factors does it look at to know that now task 3 should be done first before the rest? There are some factors it looks at. Some of you who have been using laptops, you've realized you can open a program, like for example, like Visual Basic. You open it at 9. Visual Studio, sorry. At 9 it's open. The only this one, Mr. Davis gave you. This one is smaller. But the other one, the previous one, you open it at 9, then you open Microsoft Word at 9:02 or 2 minutes past 9. And you find that the Visual Studio is not even yet what? Open. But the Microsoft Word is what? Is open. Why? Because the operating system is seeing. Are you getting me? It's trying to compare which one is more important now, in this case. There are some factors looked at. Which one should be attended to first? Let me open Microsoft Word first before the Visual Studio. Are you getting me? So there are some factors looks at. In that case, we'll be looking at resources. You see? Do you have all the resources needed for Visual Studio to be open and work? Because it requires a lot of resources, a lot of memory space, a lot of graphics. If they're not yet available, then should wait. Let me first open Microsoft Word. Are you understanding? You getting me? And that's why some of the programs don't act very fast on your computer. Because now the operating system, first of all, then give them what? Priority. Because of certain what? Factors. So I want to look at those factors right now. And you know which factors are considered when the operating system is deciding the order in which tasks should be performed by the processor. Which factors does it look at? Number 1, it can look at what we call the resource requirements, the availability of the resources, availability of resources needed by the job or the task. When the task is going to be performed by the computer, there are some things that are needed. If those things are not present, then the processor cannot perform that task. Those are called resources. They're called what? They're called resources. If they're not there, then the processor does not bother. The operating system does not bother to make that task to be performed because there are no resources. There are no what? There are no resources. The things to be used to perform the task are not there. What things are those? Some of the resources that are very, very important are the memory. The main memory is a resource. Why is a resource? There is no task which will be done by the computer if there is no main memory. In year 12, you learned that any instruction to be performed must first of all be put in the memory. After it's put in the memory, that is when the processor now knows that this instruction, I can do it. Because the processor only knows the tasks, it only knows which tasks to do when it finds them in the memory. If there's no memory, or if there's not enough memory space, that means instructions won't go there, and it means that those instructions cannot be what? Can't be performed. Are you getting me? You have an instruction to be done, but then the computer tells you, wait. It says what? Wait. Why? Because there's no memory space. And without memory space means that you cannot be in the memory. The processor won't see you anyway. Are you getting me? So it becomes a resource. Then we have what's called processing time. Processing what? Processing time. Processing what? Time. Now this one can be in terms of there's some computers that assign amount of time the processor should take with a task. If that time is done, then that task cannot be performed because it means your time is over. You cannot perform you. But if there is time, if your time you need is still there, then we can what? We can perform you. What do I mean by that? Now this happens when a task is being done, but then it has been assigned. So maybe it needs to be processed for 5 minutes. Now when the 5 minutes are over, it means that the operating system will have to remove you from the processor because your time is what? Your time is, are you getting me? Your time is over. So if a job still has its processing time and does not use it up, it means in that case, it can be given what? It can be performed, which means now this one becomes also a resource. But there are some other resources. We have what called graphics, for example. Graphics are also resources. We have what called the utility softwares. Remember utility softwares from year 12? They're also a resource. For example, if you're having a hardware device like a printer, it cannot work without the printer drivers. So if you say print, the person can't waste time if they're not drivers. You see? Because the drivers are the ones going to tell the computer that this task needs to be what? Needs to be printed. Are you getting me? Understanding? Those will become what? Resources. So without enough resources, it means that a task is not supposed to be done. So on that point, under the factors, availability of resources, the point there is that if the resources needed by a job, are getting me, are available. If there are enough resources that, if there are enough resources a job requires, is it okay? If they are available, then it can be given priority to be performed. But if the resources a job needs to be performed are not available or they are not enough, then that task cannot be given what? Priority to be what? To be processed or to use the processor. We have what called waiting time. Waiting time is another factor. In your book, how do you write it? The amount of time a task has waited without being what? Without being processed. Sometimes, if the system realizes that there's a task which has been waiting for a very long time without being performed or being processed, then this time the person can say, no, is it okay? Let me choose you first too. Let me favor you. Let me give you priority to use the processor. So it will give it chance to use the processor. Why? Because there are some scheduling methods that don't allow some jobs to be performed, especially long jobs. They will keep on waiting and waiting and waiting. Understand? So if a programmer comes, he has to program and say, if it waits for long, like for 10 minutes or 20 minutes, no. Give it chance to use the processor first. Next, we're about to call if a job is I/O bound or processor bound. Whether a job is an I/O bound or processor what? Processor bound. That one also determines if a job, are you getting me, should be given priority to use the processor or not. Priority means favoring it most. Now, you need to know, we get back here, that we have got two categories of tasks in a computer. We have what called the I/O bound jobs or tasks and the processor what? And the processor bound tasks or the CPU bound tasks. An I/O bound job or task, I/O bound, written like this. An I/O bound job or task is any task that needs more time with the input and output what? Devices than the time it needs to be with the processor. It is a task that needs more time with the input and output what? Devices than the time it needs with the processor. An example is a printing job. If I'm printing work, it means that most of the work is going to be done by the printer, which means that what the operating system does or the processor is just basically to instruct the printer. That is all. But most of the work, the printing, is being done by the what? By the printer. I'm printing 1,000,000 papers. The processor doesn't do a lot with that command. No, it is the printers doing a lot of the printing. So the processor only does one task, just to instruct the printer. Now such a job becomes an I/O bound because it is using, are you getting me? It's spending more time with the input and output devices. Then what we call the processor bound jobs or the the CPU bound jobs. The processor bound jobs or CPU bound jobs, those are tasks, computer tasks that need more time with the processor. They need to spend a lot of time with the processor. A lot of time with the processor. An example is if you're computing marks or final grades for students like in Cambridge, you enter all their marks and say grade. You see? So the grading is being done more by the processor because there's addition, there's the if function, the decisions, which grade, you see? The processor does, most of the tasks the processor does is arithmetics and logic. I think you know that. The arithmetic what? The arithmetic and logic what? Tasks are the ones that the processor does most. The thinking and the calculations. So if you have a task that needs a lot of calculation and thinking, then that is one spends a lot of time with the processor and becomes what's called a processor bound what? Job. The question is one, if I have an I/O bound job, if task 1 is an I/O bound job and task 2 is a processor bound job, which one will be chosen first to use the processor? The I/O bound what? The I/O bound job will be chosen what? First. But why? Because the operating system will say, task 1 your I/O bound. Use the processor first. Task 2 you can wait. Why do you think? And a very brilliant answer. Why do you think task 1, which is I/O bound, is going to be favored to use the processor first before task 2? Are you sure? That's not that's a fact. That's a fact. But then why? Okay, just 5 more. How is that good? Are you getting me? I want more. Yes. Okay. The reason saying since it is less time, the process will be carried out what? Very quickly. But I want another point I need. Eh? How can I answer us a point there? Why is that good? Because it is chosen because it is good. Should be an advantage to the computer system. Why do you think that is good? Why is that an advantage? It will give chance to be attended to very what? Quickly. So that one gives chance, a quicker chance for other tasks, not programs, but other what? Tasks to be attended to or to be processed what? Quickly. Because if it is as a process of a short time, it means by leaving it means now it's giving chance to other what? Tasks to be attended to by the processor very quickly. Than task 2, which is going to keep the processor for 1 hour. And then other jobs like task 3, they are waiting for a very long time. That's the main reason why. Are you getting me? Very good. Next. Which other factor is there? Now, the other factor which is there is the importance of a job. That's another factor which can be considered when giving priority to tasks or choosing the order it should be processed. How important a task, the importance of tasks. The importance of what? Tasks. Now, what we mean here is this. There are tasks that are very important in that if they are not performed, then they can be a very big what? Impact. There are tasks that must be done very, very quickly because they are very, very important. And if you're understanding, they are very what? Important. So they have to be done very quickly, otherwise there will be an impact. Yeah? Are we there? Because they are very what? Important. Now, this point is trying to say here is that if a task is very important and crucial, or critical, it must be chosen to be done first. It's given higher priority. Why? Because if it's not done very quickly, are you getting me? Then the impact will be, there'll be a very big impact or a negative impact in its purpose. Are you getting me? An example is, you go to the ATM and withdraw money. When you're withdrawing money from the ATM, it is a must that your account must be updated immediately. Immediately. To show that now this is your new account what? Balance. That one becomes a more critical task. Why? Because if you don't update, it means that there's going to be an impact on your account balance and even on the decisions that the bank are getting me, decisions and the performance of the bank. That's fine. So I've given you the clear ones, the easier ones. So what you're going to do, okay, when you're revising questions, we shall have to look at examples of what? Resources needed by tasks. I think in year 12 we did this. Okay? Main memory, which is RAM. There are things like hardware drivers. You shall get them more as we revise. Those are the factors. Next, what are the objectives of job scheduling? Why is job scheduling done? Why is it done? Number one, to make sure the computer is fair to all what? To all tasks. To be fair to all what? To all tasks. To be fair to all tasks. Being fair means what? Fair means that to allow as many tasks as possible to be processed or to get a chance to use the processor. That is one. Then it can be done to maximize the use of the entire computer what? System. To maximize the use of the computer system. How do you explain that in the exam? Okay? If job scheduling is done, it means that very many tasks, there will be a chance of very many tasks being what? Being processed or being performed by the computer system. So instead of having so many tasks waiting but not done, if you have job scheduling, it will allow many to be what? To be done by the computer system, which means you're maximizing the use of the computer system. Why do we need to maximize? Because we buy these computers and we have to use them to the maximum. You understand? Mhm. Next, to prevent system what? Failure. System failure, I'm talking about the hanging. Hmm? Computers keep hanging all the time. My computer is hanging. Eh? Who has ever experienced that before? You open your laptop, you open things and it hangs. And then becomes slow and tells you close this file, close that file. Who has ever experienced that before? Then we tell you, please, need to install the operating what? System. You get? Why? Because maybe viruses are there. But in most cases also, another cause of that now is lack of enough what? Resources. Lack of enough what? Resources. You open GTA, you open Power DVD, you open Windows Media Player. They're all open. Are you aware that GTA, Windows Media Player, and Power DVD, they share some resources? They need some. Are you aware of that? Which resource can they share? In that case, they all need sound. They all need what? They all need sound. They also need graphics. They also need what? So if your VGA, I think you know what a VGA is, displaying what? Images on the screen. If your VGA, are getting me, doesn't have enough graphics, that means the computer is going to tell you, please, you hold on, or you close one of the programs. Why? Because you're opening so many programs, the resources are not there, and then the computer cannot keep on seeing that and wasting time. To just basically tell you hang and tell you wait. By hanging, it means you're giving so many instructions, but the resources are not there. So we are wasting time. You cannot perform them. So when it hangs, it is allowing some of the resources to be used by only one program and then leave them free. So that now when they are free, that's when your program also does what other programs resume. Are you getting me? Understanding? So that's what basically that point means. And comes from availability of enough what? Resources. If they're not there, it means the computer will have to hang and let those few resources be used first by other tasks and then later release them for other tasks instead of different tasks competing for them. Those are the objectives that are clear. Let's move on. Next, job sets. Job what? Job sets. Job sets. A computer task can be in three stages. Three what? Stages. And we call them states. Call them what? We call them states. A computer task can either be in a ready state, or it can be in a block state, or it can be in a running what? A running state. Oh, guys, all these things can be asked. You see past papers there. There. So if a job is in a ready state, it means that this is a task which is ready to use the processor. It is ready to be processed. And where is it located at that time? If it's ready? In the main what? Memory. So it's in a ready state. It's a task which is ready and waiting to use the processor. If a task moves to the running state. It means now this task is being processed. It's actually being performed by the processor. It means at the running state, it is running. It is being attended to by the processor. Then if a task is in the blocked state, it means no longer needs to use the processor. It's in a blocked state. It doesn't require to use the processor. Have you understood? Have you understood? So, if you want to, let's use an example. I have some work to print, and I command print. When I command print, it means that work or that command print. Is it okay? At first, it will be in the ready what? In the ready what? State. Because the moment I click print, at that time the processor cannot begin printing what? Commanding the printer immediately. Why? Because that instruction has first of all go to the what? To the main memory, the ready state, and wait. Now the moment it's picked by the processor, now it's in a running state. That's when the processor now begins executing it. It makes sure it is performed. And making sure it's being performed, it means that now that command is being sent to the printer, and the printer begins doing its work. Now once the work has been printed, is it okay? It means now moves the block to what? I don't need the processor anymore. I don't need the processor. Which means if I have work on my flash, but I'm not yet using it, it's also in a blocked what? State. Then I need the pro. Are you getting me? Very good. Next point. Tasks can move from the ready state to go to the running state. What does it mean if we say that a task is leaving the ready state and going to the running state? What does it mean? What does it mean? Are you getting me? It is now it's going to the processor. The processor is what? Is picking it from the memory. But tasks can also be in a running state and then move back to the ready state. When does that happen? That happens especially in two situations. When there's an interrupt, are you getting me? Or when a job is being done, but its processing time is what? Is over. Are you getting me? Another scenario is a job is being done, but there are not enough what? Resources. Just go back to the ready what? State. To wait there, why? Because the other jobs can be performed. So it has to go there and wait. All those questions can be asked. Then a job can leave the running state and go to blocked. This happens when it has been processed. Then it can move from blocked to go to ready. From blocked to go to ready. This one happens if a task is going to be, needs to be processed, or when it has been processed but it needs to be done again. Are you getting me? It needs to be processed again or to use the process again. That one also happens. All this can be asked in the exam, guys. Is it okay? Very good. Next, question number 1. Why do you think scheduling happens? Why do you think scheduling happens? Is it in the ready state, blocked, or running? All those can be asked. Why do you think it happens? Huh? Where does scheduling takes place? Job scheduling. Why is it? Why does it take place? It happens in the ready state. Is it okay? Because ready means we are waiting, but then we need to be organized. We should use the processor first. All those can be asked in the exam. Now, which programs pick instructions and put them in the main memory? Or which programs take instructions in the ready state? Which programs take instructions from ready to running? Which ones pick them from running to blocked? You get? Now, that's done by the operating system. The operating what? System. But here, they went further to give us parts of the operating system that do that, but it's not so important. Okay? Because they're saying part of the OS that's called the high level scheduler makes sure a system is not overloaded. Are you getting me? The medium level scheduler, this one swaps jobs. This is also important for you. What you need to know is basically for you is that it is the operating system that does the taking the tasks to the ready state, shifting them from ready to running to blocked. This will not be asked on your exam. But then from there next, we need to know that we have different programs that do what we call scheduling. And this is why I want you to be very, very attentive now. We have different programs that can be written to do what? Job scheduling. What does that mean? Right now, what I'm looking at is scheduling algorithms. Job what? Scheduling algorithms. Job scheduling what? Algorithms. Now, these are different ways how job scheduling can be done. What we mean by this is this. I can wake up and say, for me, the method which is going to be used for job scheduling is first come, first serve. Meaning what? That a task which joins the ready state first should be processed first. That is my algorithm. Then I can come and say, no, I'm writing another program, another algorithm or program for job scheduling. You can say, no, me what I want is a job which needs a very short time with the processor should be scheduled to be processed first. Understand it? Are you getting me? How jobs are scheduled can be done in different ways. And those different ways are called scheduling algorithms. And these are the ones. We have what we call first come, first serve. First served, actually. We have shortest job first. We have round robin. Shortest remaining time. Mark feedback queues. Which ones of the three of these ones is new syllabus? I think some were removed. I think the first three, is it? In your syllabus. Not first three. I think it's first three. In the syllabus is first three. You get? Now, let's just pay attention. If you're using the first come, first served job scheduling algorithm, now that means that a task which is put in the ready state first is the one to use the processor first. A job which is put in the ready state first is the first one to use, or it's the one to use the processor first before other jobs. That is first come, first what? Served. Shortest job first. Shortest job first means that a task which needs the smallest time, the smallest processing time, which needs to take the smallest processing what? Time, uses the processor first. An example. If I have an instruction which is going to add two numbers and give me their sum, and I have an instruction which is going to receive marks, get the average, and then get the marks, which task needs more time with the processor? What? You see? The task which is going to receive marks, grade them, get average, and again output the grade. It needs a lot of what? Time with the processor. But then now it just adds two numbers and gives me what? The output. Now it needs just a short time with the processor. So that one is given what? Priority to use the processor first. Then we have what called round robin. Round robin. Round robin, this is where tasks are given a maximum time that you use with the processor. If that time is over, those tasks must leave the processor, whether they have been finished or not yet what? Finished. So they are given time slots they should take while using the processor. The maximum time they should take while using the processor. If that time is over, if they're not finished, they are removed from the processor and taken back to the ready state. If they are finished, they're taken to the blocked what? Are you getting me? Question 1. The question is, no, the point now is, these algorithms can either be preemptive or what? Now, those are types of scheduling algorithms. So take note, the scheduling algorithms are the first come, first served. Those are the algorithms. But then the types are preemptive and non what? Which one is preemptive? Round robin is preemptive. Why? It is preemptive because once its the time it has been given to use the processor is over, and it has not been done, it has to leave the pro. It is forced to leave the processor. So with round robin, oh sorry, with preemptive policies or algorithms, is it okay? Those are algorithms that force tasks to leave the processor. They force them to leave the processor. In case those tasks are not yet done, but their processing time is what? It's over. Then we have what non-preemptive. Non-preemptive, those are scheduling algorithms that allow tasks to be done until when they are finished. They don't leave the processor before they are finished. Is that okay? Is that fine? So, the next thing now is to see how they come in the exam. The other two you'll see. Mr. Ahmad, are you coming? You first come and show my students for just 10 minutes. Okay, let me show them here. Next time we'll explain to them. So that's about job board scheduling. Memory management, we finished.